Hello and welcome to Practice Problems for Homework 11b. I hope you are well. We'll get started in a second, but first, as usual, I just want to remind us of what we should do in preparation for this. You should have already watched the lecture for handout 11b and solved the numerical problems in the lecture from scratch. And I've modified this guy a little bit to say have your lecture handout or the concepts, definitions, and formulas at hand. Either one is fine. The lecture handout, it might be a little bit harder to zero in on a formula that you're looking for, but everything in concepts, definitions, and formulas, and so much more is in the lecture handout. So you can use either one, whichever you feel more comfortable with. All right, so let's jump right in here. So I've got several problems for us to look at here. The first is a set of capital budgeting questions that relates to this data. So let's read the problem statement and see what we've got. For the following capital budgeting questions, consider this information. The company's capital budget is $400,000. Opportunity cost of capital is 12%, as it doesn't say anything else. That would be for all the possible projects. And the company is considering these three independent potential projects. So we know for each project we have the cost of it and we have the NPV. And remember, the costs are built into the NPV because the NPV includes the present value of every cash flow, positive or negative. So that's going to include, of course, the cost cash flows at t equals 0. And also, someone has computed for us the BCR for each of these projects and the internal rate of return for each of these projects. So that's what we've got. So question number one about these guys is what DCF evaluation rule should we use to determine which projects to pursue? And the answer to that is clearly the NPV rule. And we're going to choose combo of projects that maximize total NPV without going over budget. Okay, so clearly I've given you some information here that we're not going to need and it's not relevant. I need you to know when you're doing capital budgeting stuff that you need to do that with the NPV method and your overall budget. Okay, so that's number one. And number two, now we're getting down to the nitty-gritty here. Which project should we pursue? Okay, and in lieu of using a linear optimization model, which is beyond the scope of this course, there's really only one way to do this. This is to look at the project, think about what combinations are plausible, and for each of these plausible combinations, write down the total cost and the NPV. So let's look up here. We've got, so their budget is, I believe, 400,000. And again, I'm never going to trick you with units. So these are 400,000. These are going to be the same units of K here. I'm never going to try to pull a fast one. And BCR is dimensionless because it's $K over $K. And IRR is same thing. It's just 8%. Okay, so for Project A, we could do Project A and Project B and not go over budget. And we could do Project A and also Project C and not go over budget. So let's start putting in some combos here. So let's say AB and the total cost is going to be equal to, for A and B, the cost of A plus the cost of B, okay? And the total NPV is just going to be the sum of these two NPVs. All right, so we also said we could do A and C, okay? And so the total cost here is going to be 45,000 for A and 150,000 for C. So you can see we're not over budget, okay? And so far, AB is the winner because that would give us the combination of these two projects, give us the highest total NPV, and that's what we're shooting for. Okay, so what else would be possible here? Let's think about B. So we've already done B in combination with A. right? That's right here. So we don't have to worry about that. So could we do B and C without going over budget? Wow, I can even do this math in my head. If I do them both, I'm going to be right at 400, which is our budget. Let's see what the budget says. It says it's 400, so we can go up to the budget. So let's look at B and C in here. And so the total cost will be our 250 plus our 150. Whoops. And we've got that, and the total NPV for B and C is 35,000. So now we have a new winner. It looks like B and C is the best, but let's see if there's any other combination that we haven't thought of yet. I think we've pretty much got everything here. There is maybe one more. How about this? How about if we do all the projects, A, B, and C? Well, some of you have seen this already, but that's not going to work because it goes over budget. Okay, so we can't do that because it's over budget for us. So given all the plausible combinations, I think the thing we'd want to go with, in fact, I know the thing we'd want to go with is B and C. So we'll put in a green, good for that, happy for that, and that would be our answer. We would choose B and C. Okay. And finally, here, a question on the payback method. So we have the payback method may be appropriate to compare projects when we need to apply a simple DCF comparison method. We could not compute the info needed to compare projects using NPVs. We need to recover our costs by a time certain or face bankruptcy. Okay, so let's just say that you don't remember exactly everything that was mentioned about the payback period during the lecture. So you want to call up a friend here, and you can either just use the in-class notes or you can use the concepts, definitions, formulas. Either one is going to get you there because we're going to use the awesome power of search, right? So using the class lecture notes here, I look for payback, okay, and this time I kind of got lucky. I found it right away. Okay, so first thing it says here is not a DCF method, does not consider the time value of money. So let's see. That's clearly going to be the wrong answer. Okay, don't want that because it's not a DCF method. Okay, we could not compute the info needed to compare projects using NPVs. I can't really imagine when that would ever be the case unless for whatever reason we couldn't estimate an opportunity cost of capital, but we can always estimate an opportunity cost of capital one way or another. So let's move on from that. Let's not make that red yet, but let's move on. We need to recover our costs by a time certain or face bankruptcy. That sort of rings a bell. So let me just poke through here. We go through this example showing payback says one project is better and NPV method says another project is better. And then down here, we say, however, if we're a small company that needs to borrow money and pay it back at a time certain, like, for example, the end of 1 year, they could do project A, but they couldn't do project B because their loan comes due and they go bankrupt. Good example of that would be a construction loan type thing. That might be a 12-month loan that comes due, you got to pay it back no matter what. So in this case, they'd have no choice but to go with project A, and in that case, the payback method would be the method of choice. And also, let me just show you, we could do the same thing here using concepts, definitions, and formulas handout. Okay, so we look for the payback period. It says it's not a DCF method, and it tells you when it may be okay to use it. When the quickest payback, because we might go bankrupt if we pursue a project with a longer payback period. So based on both of those notes, this is clearly what we want here. So we'll take this one and make that one red too, and we'll make this one green to show green for go, green for good, green for the correct answer, and that's it. Okay, that's all I've got for homework 11b. Most of the problems are very similar to the problems given in homework 11a, with the proviso that you're computing NPVs and things for two projects and deciding if you can only choose one, which one is best. The answer to that always is the project. If they're mutually exclusive equal length projects you're looking at, the answer is always the project with the higher NPV. Okay, so that's it for practice problems for homework 11b, and I look forward to talking with you again soon.